So how do we write the formulas for ionic compounds? Well, if you're given the ions, remember the goal is to put them together to make a neutral compound, a charge of 0. So positive and negative ions come together and the charge has to equal 0. So here you see I've got some cations down the left and I've got some anions across the top. And I've got them kind of color-coded by the charges. Well, when you've got two ions that are equal and opposite charges, then you just put them together, one of each ion. So like sodium is a +1 ion, chloride is a -1 ion, so the formula is NaCl, sodium chloride, one of each ion. And so sodium +1 and up here hydroxide, OH -1, again, I just need one of each ion, so the formula is NaOH. Same thing here. NH4 +1, that's ammonium, with Cl -1, ammonium chloride. You put them together. Same thing, NH4 +1, ammonium, and hydroxide, OH -1, one of each. And this can be if they're +2, -2. Like here we have calcium, the calcium ion is +2, and up here I've got sulfate, SO4 -2. +2, -2, I just need one of each, CaSO4. If the charges are not equal and opposite, you have to put them together so that they do end up canceling each other out and getting a 0 charge. So if I put sodium, which is +1, with sulfate -2, I'm going to need 2 of the sodiums to balance out the -2 charge of the sulfate. So +1, +1, that makes a total of +2, and that cancels out the -2 of the sulfate. But you'll notice, very important, in these compound formulas there are no charges. When you put them together, they are 0. So you have just a formula without any charges written. And when you need more than one of something, the number goes down in subscript form. Take this one, calcium +2, chloride -1. I need 2 of the chlorides to balance out the +2 of the calcium. This is an important one, calcium +2 and hydroxide -1. Hydroxide is a polyatomic ion. And when you have more than one polyatomic ion, you must put that in parentheses. So Ca and then 2 hydroxides. That's because this Ca, again, apologies for my handwriting, OH2 is a different formula. That would be 1 calcium, 1 oxygen, and 2 hydrogens. But we want to say that there's 1 calcium and 2 hydroxides. So that's why we put them in parentheses. Showing you a couple more. Iron +3 and chloride. So I'm going to need 3 chlorides to balance out the +3 of the iron. Here we've got +3 iron, -2 sulfate. And here we're looking at, a +3 and a -2. What's the least common multiple between them? And that would be 6. So I need both sides to end up with a +6 and a -6. So that's why the formula is Fe2SO4 3. 2 of the +3s makes +6. 3 of the -2s makes -6. A little hint that sometimes you can think of is called crisscross. If the charges are not equal and opposite, like here we have +3 and -2. Well, then you can crisscross the charges. And what that means is, since this is Fe +3, I'm going to need 3 of those. And SO4 -2, I'm going to need 2 of those. So it's Fe2SO4 3. If that helps you, great. If the least common multiple of 6 helps you, that's great too. A couple more. Fe +3, hydroxide -1. Again, make sure those parentheses end up around hydroxide when there's more than one. I didn't need them here or here because I only had 1 of the polyatomic ions. And here's the last example. Ammonium +1, sulfate -2. I need 2 ammoniums to cancel out the -2 charge of the sulfates. So that's what that formula looks like, ammonium sulfate. And you can start to recognize the parentheses and all these lovely formulas like when we were calculating molar masses. And that's how these compounds are put together. So looking at your lovely assignment to write out all of those different ionic formulas, to be successful writing all those formulas, you need to know where are you getting the ions from. So I didn't obviously hand you the ions like that matrix on the previous page, so you need to look them up. Where can we find them? Well, obviously on your lovely friendly ion sheet, your friendly ion card. I also gave you a list of polyatomic ions, which you probably don't have memorized yet. We made that I'd list on the back of your notes packets, and that lists all of the ions that end in "ide." And a little hint, if a word ends in ate, ite, or eum, that means it's one of our polyatomics. So taking a look at a couple examples. Again, the first one there on your sheet, sodium chloride. So I see sodium chloride. So I've got to find the sodium ion and the chloride ion. Well, those are going to be on your super friendly ion card. When I look at the top of my super friendly ion card, I find sodium here and I find chloride here. And so those are my ions. And so from the card I saw that sodium was a +1 ion, chloride was a -1 ion, and now I know I can put them together and create the formula NaCl because I need one of each ion. If you go down a couple rows to lead 4 cyanide, well, where do I find these ions? Lead 4, I can look on my super friendly ion card, but remember that Roman numeral of 4 means that lead has a +4 charge. Cyanide can be found on our Ide list. It's one of the polyatomic ions, and it is Cn with a -1 charge. So when I need to make this compound, I need 4 cyanides to balance out the +4 of the lead. And I need to remember to put those cyanides in parentheses to write the proper formula. One more example, again going down that same column to gallium phosphate. Okay, again I need to find these ions. Gallium is an element, so I will look on my super friendly ion card. Gallium is here in group 13, and you see that it is a +3 ion. Phosphate ends in 8, so it is one of our polyatomic ions. So when I look at my polyatomic ion list, I see phosphate here is PO4 -3. Having them memorized really helps, but for now you can look and find what phosphate is. So again, now I know that gallium is a +3 ion and phosphate is a -3 ion. And since I have +3 -3, that means I need one of each ion. So my formula is GaPO4, gallium phosphate. So that's how we do those. If you want to take a peek, here are some answers. This is the front side, the first couple rows. So you can see if you are doing them right. And then these are the first couple rows on the back side. Remember that these guys, stannic, mercuric, and ferrous, those are the old school classical names, and you can find those on your super friendly ion card. And so again, stannic is that ion, mercuric is right there, and ferrous is right there. That's how I found those ions and their charges, their formulas. So good luck writing the rest of those formulas, and I hope you do okay.